Hello and welcome to our technical deep dive webinar in partnership with NVIDIA. My name is Maz Lopez and I'm Head of Marketing for Boston Limited. I'm delighted to be joined today by NVIDIA Senior Solutions Architect Paul Graham, Boston's Head of HPC Dave Power, and HPC Commercial Manager for Boston Matthew Parfit. In today's webinar, we'll be taking a technical deep dive on the recently announced NVIDIA A100 architecture, including the NVIDIA DGX A100, a universal system for AI infrastructure. But first, a little bit about Boston. With almost 30 years in cutting-edge technology, Boston has a global footprint and provides high-performance, mission-critical server and storage solutions that can be tailored to each specific requirement. Boston is NVIDIA's most accredited elite partner across Europe. That's in HPC and Tesla, DGX and Quadro competencies. And we are also global delivery partners of the NVIDIA Deep Learning Institute. So without further ado, I'll hand over to David Power, Boston's head of HPC.
Excellent. Thanks, Maz. So just before we get into the exciting part of the presentation, I guess I just wanted to kind of cover what we do at Boston, sort of around delivering these GPU products as an overall solution. And there's a range of capabilities that we have within the organization that can kind of assist customers in, the reassurance of working with an organization that understands what the requirements are to deliver not just the technology, but also the services around it to ensure that you get the most out of your investment. And we kind of have this circle of services really that takes us around the whole commercial engagement around delivering solutions. So typically, to start off with, we invite customers into our labs facilities. We've got a HPC profiling center, which I'll cover a bit more on one of the next slides, but that's an opportunity for people to come in and actually do benchmarking and testing, not just on the GPU components, but also some peripheral components as well, like fast storage, NVMe, even high-speed memory devices and high-speed fabrics as well. And then, when it comes to the delivery of the system, we've got 20 years of experience in terms of delivering HPC solutions. So we've got a team of project organizers who can actually work with customers to arrange logistics and ensure that we have scope of works and project test plans in place, so that when we do deliver systems, everything is actually to spec and configured exactly as we need it to be for that individual customer. We've also got a dedicated integration facility. So this is actually where we do a full assembly of a cluster or a solution in its entirety. So this is when we bring together the GPU servers, the networks, the storage, the software, build it all together as it would be on a customer site, and actually test and validate the system to iron out any sort of kinks or chinks within the overall platform, with the idea being that we reduce the time to production once we get to delivering the system on site. Over the years, we've developed our own cluster validation tools as well. So this helps with validating large-scale systems. So we have written software from the ground up, which goes in and validates every component within each individual server, goes across the fabric, checks all the disks and SSDs to make sure that they're all performing correctly, and gives you a kind of a traffic light report to help highlight any any components that not necessarily may have failed, but are actually performing in a degraded state, or not delivering the performance that we actually require the systems to deliver up to. So it's a great way to kind of identify the needle in the haystack issue should anything go wrong with your system over time. And then finally, we have a team who are here to assist you with the managed services side as well. So if you had a team who wanted to just focus on using the system rather than the day-to-day administration, we can actually facilitate remote managed services on the system, where we'll come in, make sure that everything is running correctly, work with you in getting new applications installed and rolled out, profile existing codes to make sure that they're performing as you'd expect and scaling as you expect, and as and when engineers are needed on site, get those out to fix any components that need to be done on the system as well. So yeah, there are some of the peripheral services that we can provide from our side. Excellent. So in the labs area, I touched on it briefly in the previous slide, but we have HPC and Kubernetes clusters inside in our facility, where we have all of the latest technologies available for customers to come in and test and benchmark on. So if you wanted to check different memory configurations or CPU configurations, or even test the different GPUs to see, do I want to use something like a T4 for inference? Do I want to get an A100 to do absolutely everything? Is there a mix and match of what the best overall products are to meet the application's demanding workloads? We can put that together in our lab facility. We have, NVMe, SSD, very fast storage to ensure that the GPUs are kept busy, incredibly fast fabrics from Mellanox as well to ensure that that data is delivered up to the system, and engineers to work with as well who will help you in terms of profiling your codes and ensuring that when you're selecting your hardware configuration that it's working and performing as you'd expect and delivering the performance you require for your application. Okay, so I'd also mention on that slide as well that we do have A100s on the way in, and if people were interested in doing some benchmarking on that, to get in touch with us and get your name added to the queue as well, as there will be a lot of demand and interest in that as well when it does come online. We're also one of NVIDIA's deep learning global delivery partners, so we're part of their Deep Learning Institute, and this means that we go out and we deliver labs and learning material in-house or online, so that people can actually understand some of the fundamentals around using the CUDA framework or running some of the deep learning frameworks, and we can actually come in and run courses on behalf of NVIDIA to train up organizations in utilizing the underlying hardware in a much more efficient way, and get going in terms of the AI journey that people are undertaking at the moment as well. Okay, and I'll just very briefly mention as well, so alongside all of the hardware that we deliver as well, we've also got a comprehensive software stack that we use for delivering GPU and AI reference architecture solutions. So we've been working with the vScaler team to essentially convert these GPU systems and storage into an API-driven infrastructure, which means we can actually come in and allow users to self-service and self-manage all of the underlying infrastructure and either roll out software environments such as Kubernetes, or if you wanted to do something more batch-oriented, we support Slurm as well. We can deliver GPUs, be them as bare metal servers, so we can actually take DGXs and have them provisioned as part of our orchestration system, or we can actually virtualize as well, which allows us to pass through individual GPUs into instances, which are a little bit more useful when it's down to sort of the initial investigation side or doing more proof of concept work. And we also support virtual GPU then as well, so we have a number of customers who are actually using this product as part of a training course to deliver virtual systems to researchers and carve up the GPUs into much smaller chunks, so it's much more cost effective for users in terms of delivering GPU capability to their researchers, but also then allows them to work off the exact same software environment, be it CUDA, and port onto a bare metal environment then afterwards when it comes to running at scale or running at production as well. So there's hopefully a link at the end. There's a white paper that we've done on that, which covers it in more detail if you're interested in that. Right, so just to cover some of the customers actually that we've been working with as well. We've been working with a number of genomics organizations over the past while, and we're starting to see the interest and adoption from this vertical change from being kind of exploratory and investigative into much more production usage. So first of all, they're beginning to use AI techniques as an augmentation to the existing research tools to help with identification and classification of rare diseases within genomes. And GPUs are actually helping us to hugely accelerate the amount of scientific workloads that have been put through within this particular organization and customer. And we've also been working with a number of automotive organizations, and this was quite an interesting project that we engaged with, because we actually had a customer that was kind of beginning their journey into kind of using AI as part of their autonomous vehicle and object classification system. At the start, they had this problem with they had a number of distributed users who were spread all over the world, and one of the challenges they had was actually getting them data sets to go and create this golden image repository of known good data to actually go and train their neural networks further on down the line. So they had this mammoth task of splitting up video feeds that were coming in from the camera, distributing them then to hundreds of people and consultants within the organization, who were then spending hours going through each individual frame, classifying, traffic lights, cars, objects, people, hazards, and so on. And they ended up spending the vast majority of their time sort of coordinating that distribution of files and data and recollecting them and merging them. And one of the first things we did was when we put in vScaler, it centralized all of the access. So we kept all of the data sets internally on very fast parallel file systems at the back end, and provided them with a remote ability to provide workstation capability through virtual GPU into the system to allow all these consultants actually work on the data sets directly. And that had the peripheral benefit of much more security and governance over the data sets instead of having to send them out to people remotely. A lot of the IP and a lot of the value in the organizations was in the actual data sets. So it allowed them to put much more strict controls over how people access the data. And then further on down the line, we were able to take those virtual GPU instances and repurpose them into a GPU cluster for then training up the neural nets once all the data sets have been created. And this was all done with vScaler and Kubernetes, and then we were able to roll out and actually run a kind of an inference as a service where they were doing live classification then of the of images and video feeds coming through the system then afterwards, and GPU was at the core of all of this to help accelerate the particular organization's workloads. So yeah, great use case study, and looking forward to working with them more in the future as well. Okay, excellent. So with that, let me pass you over to Paul Graham from NVIDIA, who will take you through some of the A100 speeds and feeds.
So thank you very much, David. So good afternoon, everyone. I'm going to be speaking about the new A100, which we announced 2 weeks ago. If you just give me a moment, I'll get my slideshow going. Hopefully you can all see the slides now. Today I'm going to focus on the A100, which is our new GPU, which we're very, very excited to see come out. So to give you a bit of background to this, what's the motivation behind some of the features we're going to look at? So in terms of data centers, and especially in terms of AI, we're seeing one of the main challenges is the different workloads that people have. So if you're doing training, we've seen a huge increase in the complexity and the size of the neural networks that people are using. And the reason these networks are getting larger is they actually give you more accurate results once they're trained. And of course, the problem here is that they take much more time and petaflops to train. So we've seen in the last 5 years an increase of about 3,000 times in the amount of petaflops required to train these neural networks. So this requires things like dense nodes, a lot of GPUs, a lot of fast interconnect between the GPUs and between the nodes. So that's one problem. On the other hand, we're seeing a huge rise in perhaps what we could consider small interactions, but many millions of them. So if we're looking at inferencing, for example, when people talk to their phones, they talk to their home devices, which answer their questions for them, and so on and so forth. There's a lot of inferencing goes on behind the scenes there. And that has a different sort of model in the data center. You still need a huge amount of compute power, but that compute power is in a sort of scale out situation. So what we're trying to do with the new hardware is to create a solution which can actually deal with both of these situations. And so you can change the configuration of your data center on the fly, depending on what demands you're seeing. So if you're doing training or HPC or something, you might need these, make use of the dense nodes. However, if you're seeing more inferencing or perhaps user interactions, people running Jupyter notebooks and things, you can change your data center without having to change the hardware. So we'll look at some of the features which enable that in a moment. So we have our new NVIDIA A100. Here's a picture of it here. And this is a huge leap in performance over the previous generation of Volta. And in many cases, we're seeing a 20x speed up in terms of computation. So if we look at FP32 training, we now have a peak of 312 teraflops, which is 20 times larger than Volta. In int8 inference, again, we're seeing a 20 times increase. And in FP64, in many cases, we're seeing a 2.5 times increase. So that's great for HPC applications as well. And we have a new feature called the multi-instance GPU. And this allows us to actually split up the GPU into dedicated hardware isolated sections, which allows us much more flexibility in how these highly powered devices can be used. So we'll look at these innovations of the A100 in a little bit more detail. So as we saw, it's a huge chip. It's the world's largest 7-nanometer chip. It has over 54 billion transistors on it, and it has the new HBM2, which has about 1.7 times the bandwidth of the previous generation. We have the third generation tensor cores. So those of you who are familiar with the tensor core technology, these are specialized areas of the GPU designed for doing hardware acceleration of matrix multiply and accumulate operations. These are very common operations seen throughout AI and indeed in HPC. And with this new generation, we're seeing much higher performance and full data type support across the spectrum. We also have a new sparsity acceleration, and this is taking advantage of the fact that once you've trained a neural network, many of the weights actually don't contribute to the final result. So you can actually ignore those or remove those, and this allows us to increase the performance of inference by up to 2x. I've mentioned the new multi-instance GPU, we'll go on that in a moment, but basically allows us much more elasticity in the data center in terms of how we can use our GPUs. And of course, we've got the next generation of NVLink and NVSwitch. So these allows us to communicate between GPUs within a node much more quickly than we could previously. And of course, we have NVIDIA very pleased to announce the acquisition of Mellanox, and of course, we can use InfiniBand between nodes as well. So this allows us to have the flexibility for both a scale-up and a scale-out solution. So let's look at this new third generation of our tensor cores. So one of the headline features we've enabled in this new tensor core is the support of a floating point type called TensorFloat 32. So previously in Volta, we introduced our tensor cores. They just had FP32 and FP16 support. Then in the Turing architecture, we added support for int8 and int4. And now we've provided support basically for all the data types which one would need for doing HPC and AI. So we have the new bfloat16 support, which goes at the same rate as FP16, and the new TensorFloat. So this TensorFloat is very useful for AI, and we're also seeing potential uses for it in HPC. It matches the range of single precision in terms of the exponent, but it matches the precision of FP16. So if you look at the precision over FP16, compared to bfloat16, sorry, it's only 3 bits more in terms of memory requirements, but it actually gives you 8 times more precision than bfloat. So the idea being is we've done many tests across many multiple models and networks and training regimes, and we've seen by using TensorFloat 32 instead of FP32, no significant effect on either the convergence or the accuracy of those neural networks, other than it speeds up the whole process. And we're very much investigating the application of this in scientific codes. Our provisional investigations look like we're seeing about 4 times speedups in terms of linear solvers for HPC codes. So it's a very interesting area. So if we look at out-of-the-box speedup for an A100 compared to a V100, we're seeing a 6 times speedup by the introduction of the new architecture and then using this new TensorFloat 32 with no effect on the accuracy of the resultant neural network. So it's really a fantastic innovation here. In terms of the HPC support, the new tensor cores now support full double precision. So if you're doing any matrix multiplication and accumulations, you can take advantage of the tensor core. This is done seamlessly for the user if you're already using our BLAST library, so QBLAST, or our tensor and solver libraries, QTensor and QSolver. This will happen underneath the bonnet, and you can take full advantage of the speed up offered by the tensor cores for your double precision applications. We have a couple of benchmark examples here. So LSMS, about half the time spent in LSMS is performing matrix multiplications, and that gives an overall speed up of 1.5 times. And the Berkeley DGW benchmark is it's a material science application using density functional theory. And again, we're seeing a 2x speed up over the previous generation. And this is both taking advantage of the tensor core technology and the general speed up of the A100. So the structural sparsity, so this is specific for neural networks, or it may be the case that we can investigate using it in other areas, but at the moment it's saying for neural networks and for inferencing. And the idea being is once you've trained your neural network, many of the weights within your neural network actually don't contribute to the final result, so they can be effectively ignored. Now, normally you would still calculate them, but you'd end up doing multiplies by 0. What we've done is provided a hardware capability of basically passing over those 0 contributing nodes, and this can give us up to 2 times better performance compared without using the sparsity. So here for looking at BERT large inference, so BERT is one of the natural language NLP, natural language processing networks, which has been very commonly used now because it's very performant and accurate. We're seeing a 1.5 times speed up by introducing the sparsity for that inference. Again, we've evaluated this across a wide variety of networks and use cases, and generally speaking, this approach comes at no cost to the actual accuracy of the networks, but does improve the inferencing by up to 2x. We have our multi-instance GPU. So I think this is one of the really interesting new innovations we have on the A100. So what the multi-instance GPU is, it allows us to have sort of split the GPU into various instances. They can be up to 7 of them, but they can actually be different sizes. You could have one instance which has, or you could have 3 or 4 instances of 5 or 10 gigabytes going across the GPU, or you could have all 7 with 5 gigabytes each, or you can have one instance with 20 gigabytes and 3 instances of 5 gigabytes, and so on and so forth. So there's a lot of flexibility here. But each instance has its own dedicated part of the processing power, has its own dedicated area of memory, has its own dedicated part of the L2 cache, and it has dedicated bandwidth. So this allows for hardware quality of service and hardware isolation. So if one of the other instances fails, it doesn't bring down the whole GPU. And I think this is a really interesting innovation in the data center. So it allows you to, perhaps if you want to use the whole GPU, if you're doing training or HPC, you can partition the GPU if you've got users coming in and want to use the Jupyter notebooks or something like that. Or if you want to do inferencing, again, the inferencing, you can perhaps do 7 instances with different inferencing happening on each instance. So this gives you the flexibility in the data center. And so what's our sort of headline piece of hardware that you can find the A100 in? Well, of course, it's we have a new DGX out. It's the DGX A100. This has 8 of the A100 cards inside it. If you consider the MIG instances supported by those cards, that gives you up to 56 different instances within one device. So you could support 56 different users or 56 different use cases within one device, or you could use the whole device altogether to do perhaps training or HPC activities. So we'll start at the top. At the back, we have 8 Mellanox ConnectX-6 network cards dedicated to clustering. So effectively, it's one network card per GPU. Again, in the world of deep learning training, especially data movement is very important. So that's why we have such a huge amount of bandwidth available to us on this device. And one of the ConnectX-6 cards is used for connecting to the storage. We have dual 64-core AMD Rome CPUs and 1 terabyte of RAM. So again, high performing CPU setup there in order to make sure that we can keep the GPUs fed and busy. As I mentioned, we have 8 of our A100 GPUs. Each GPU has 40 gigabytes of the new HBM2 memory, so that gives us 320 gigabytes total within the device of GPU memory. Each of those GPUs has 12 of our next generation NV links, which gives up to 600 gigabytes per second of bidirectional data transfer to and from the GPU. We also have the next generation of NV switch, so again, which is twice the bandwidth of the previous generation of NV switch. And what this allows us to do is to connect all the GPUs into the switch fabric so they can communicate with every other GPU at up to 600 gigabytes a second. So it's a huge amount of internal bandwidth. That's really important for the deep learning use case, where you have to share your weight between every iteration or epoch. But of course, there are many other applications where you want to seamlessly access the memory across the device. And of course, again, looking at the deep learning aspects of this, we have onboard storage as well. We have 15 terabytes of the next gen NVMe SSDs there. The idea being that if you're doing training, you can store your data near where the compute happens and not have to thrash the network across the whole system. So just a slide giving you an idea of what you could expect to see in terms of performance. So looking at on the left here, we're looking at the training performance of the BERT large network. This is compared to the previous generation DGX1 with 8 V100s in it. If we look at the DGX A100 out of the box, we're seeing a 6 times improvement in the training rate. So again, a huge leap. If we look at the middle one, we're looking at inferencing performance. So this is comparing to a dual CPU server. We're seeing one DGX A100 has an inferencing performance about 172 times more than a single CPU server. So a huge increase there. And then if we look to the right, if we think more of data analytics as an application, we're looking at the PageRank algorithm. The gray bar there on the right-hand graph represents 3,000 CPU servers. That's 3,000. The bar on the right with 13x written on it represents 4 DGX A100. So we're comparing 3,000 CPU servers with 4 DGX A100s, and we're still seeing a 13 times speed up compared for the DGX is compared to the CPU cluster. So very significant performance improvements there. So just to recap, we've looked at the new A100 GPU, the world's largest 7nm chip, with a huge increase in bandwidth, memory bandwidth, 40 gigabytes of onboard memory. We've seen the new Tensor cores providing support for all data types used in training, inferencing, and now in HPC. We've seen the structured sparsity to provide hardware support to exploit non-contributing weights in neural networks. We've seen the next generation NVLink and NV switch, which combined with the InfiniBand technology can basically improve our connectivity both within the node and across the node. And we've seen the multi-instance GPU, which of course has given us the flexibility required in the modern data center. So thank you for that. I'll pass you back to our colleagues at Boston.
Thanks, Paul. Now it's time for a very quick Q&A session. Thanks for the questions we've had so far. We've got a few minutes we can hear from our experts. So I'm going to kick off, Paul. This is one for you. Also, Dave, it might be interesting to hear your thoughts as well. Multi-instance GPU, does this mean vGPU? And how do different vGPU types and flavors work now with KVM?
Okay, so the multi-instance GPU is actually, when you set it up, it actually looks like a hardware instantiation of a new GPU. If you run NVIDIA SMI, which is a sort of command line tool for seeing what GPUs are available, it will show up as a GPU on there. So it can be treated as such. So each instance can support virtualization as well, either through pass-through or via some other system. So the thing is that this technology has just come out, as we're aware. So we're still working with Kubernetes, for example, and VMsphere and people like that to work out exactly how this is going to happen. But essentially, it will support virtualization, or you can use it as a standalone GPU without virtualization.
Ooh, and I'd add one little additional query there, Paul. Do you know if this is this something that can be changed at runtime, or would this require system reboots to carve up the hardware?
Okay, that's a good question. So the MIG instancing the card has to be rebooted to enable MIG instancing. Okay. However, once it's been enabled, you can reconfigure the actual instances without rebooting the card. You just have to make sure there's nothing in particular running on a particular instance you want to change. So once the MIG is switched on, you don't need to reboot the cards.
Excellent, thanks.
Okay, this is one for Matt, our commercial HPC manager, and you, Dave. Who do we see from a Boston perspective adopting DGX A100 technology?
Well, I mean, it's becoming more and more prominent and has been increasing in terms of the broadness of customers that it's appealing to. I mean, AI is kind of one of the killer applications that we've seen for HPC, and it's taking us very much from a traditionally academic and research environment much more into the commercial space. And I think over the last decade or so, people have been doing a lot of experimentation with perhaps GPUs that are on laptops and perhaps smaller virtual systems. I think the DGX just makes an awful lot of sense for when you're ready to hit that production button. And we also actually have customers who are using that product to actually go back and even deliver courses around training for GPUs as well. So it's a phenomenal amount of computational power that we're packing into a system. And if people have been already, say, investing the time in terms of looking at GPU acceleration for any of their codes, this is just going to bring a different level of speed up and performance to all their existing applications.
Matt, do you have anything to add on to that?
Yes, just to mirror some of those comments and add on, we've seen a huge variety of customers from, as Dave mentioned, data scientists and research academics using this solution and the rest of the DGX range for AI research, both training and inferencing, but also into the commercial world. We've seen a huge variety of customers utilize the DGX platforms for other data analytical tasks, such as finance calculations using Monte Carlo simulation, manufacturing AI to determine products through a workflow and to pick out issues along the production line, right through to image recognition in security. The limits are, well, it's limitless, the opportunity that this solution can add acceleration to, and with the new A100 that acceleration has jumped a huge amount from where we were with the V100 product.
Thank you. We've got time for just one more question. It's kind of a two-parter because I've had a couple of questions along the same kind of thread. How seamlessly can existing software switch from using FP32 to TP32 data types?
Okay, so if you're doing deep learning, we're working with TensorFlow and PyTorch and the other major frameworks to ensure that the TP32 can be used seamlessly. It's already used seamlessly within our QDNN, which is our deep neural network library. And if you are doing training using QDNN, then it will actually automatically use the new TF32 floating point type without any changes to your code.
Okay, fantastic. So, and there's just one more that's just come in because I think this is really relevant to our audience. I know that we've had some queries from our customers on this. Will A100 be replacing V100, or will both be available for different workloads?
Okay, so they will both be available going forward. One of the reasons being the A100 is just brand new, so the production levels are ramping. So I fully expect to see V100s available well into next year.
Okay, fantastic. Thank you. So thanks, Paul, Dave and Matt for joining us today. After the webinar, we're going to be sending you links to the points discussed today, as well as information on how you can register your interest in testing the A100 at Boston Labs. And we're also running a sales enablement webinar this time next week, so please do pass the details on to your colleagues. The links will be in the follow-up email as well. So all that remains to be said is thank you for dialing in today and joining us, and we hope you'll join us again for another webinar in the near future.